Section 3.1, Objective. I can distinguish between intersecting lines, parallel lines, and skew lines. Also, I can identify parallel planes. And the third is I can identify the angles formed when two lines are cut by a transversal. So most of our lesson today is definitions and identifying those things that meet the criteria for those definitions. So first of all, we're going to define what do we mean by parallel lines. Okay? Parallel lines are coplanar lines that do not intersect. Okay? And the key idea here is that they must be coplanar. In other words, they must lie in the same plane. So if I have plane N, then line L and line K are coplanar lines, and these are lines that do not cross or intersect, so we would say that these are parallel lines. And the way that we showed that they're parallel is we put an arrow on them. Okay, so we would say line L is parallel to line K. So the symbol that we use for parallel is two slashes. Okay, then we have what are called skew lines. Okay, skew lines are non-coplanar lines that are neither parallel nor intersecting. Okay, so for instance, if I have this plane M with line P, and I have another plane N with line Q. Okay, and plane M and plane N are parallel planes, but notice that the lines are not parallel to each other, and so we would say that those were examples of skew lines. Let me make this a little better here. So this is plane N, and we have the line that goes like this, and this is line Q. Okay, so so they're not parallel. The planes are parallel, but the lines are not parallel because they're going off different directions. And they're non-intersecting because the planes are parallel to each other, so the lines would never intersect. So those are skew. Okay. Then we also have the idea of parallel planes. Okay. Which are planes that are not intersecting. Okay. Okay. So all planes are either parallel or intersecting. That's the only two things that can happen with planes. They either have to be parallel to each other or at some point they're going to intersect. And then we have the idea of a line parallel to a plane. Okay. Line P is parallel to plane N if P does not intersect plane N. Okay, so up above here, if this is my line P, then line P is parallel to plane N because the planes are parallel, and so they're never going to intersect. Okay. Then we have the idea of a transversal. Okay, this is very important. We're going to spend a lot of time talking about a transversal. And a transversal is a line that intersects two or more coplanar lines in different points. Okay, so if I have line L and line N, those are two lines, and I have a third line, line T. Notice that this line, all three lines are coplanar, and line T intersects two lines, line L and line N, at two different points. So we would say T is a transversal of lines L and N. Okay, so notice that the line has to intersect at different points. So if I had this picture, okay, in this picture I have three lines, but there's no one line that intersects the other two at two different points. And so in this picture, there is no transversal. Okay, so it always has to look something like this. Okay, where you have two lines, and then you have a third line that cuts those two lines at two different places. All right. So let's look at some examples. So let's say I have this diagram. This is A, B, C, and D. And I have this diagonal. And that diagonal forms some angles, 1, 2, 3, and 4. Okay? What I want to do is name the two lines and the transversal that form each pair of angles. Okay, so 1, angle 1 and angle 4. Okay, so angle 1 is formed by this line and this line. Angle 4 is formed by this line and this line. Notice that the two angles share line DB. Okay, and so the one that they share is the transversal. Okay, so the two lines are line AB and line CD, and the transversal is line BD. Okay, so again, notice that BD belongs to both angle 1 and angle 4, and that's the key to make it a transversal. Okay, how about number 2. How about angle 2 and angle 3? Okay, so angle 2 is formed by this line and this line, and angle 3 is formed by this line and this line. Okay, so which one do they share? They share, again, line BD. Okay, so line BD would be the transversal, but in this case, the two lines are line BC and line AD, and the transversal is line BD. Okay, so it's really important to identify the line that belongs to both angles, and that is always the transversal. Okay, because some diagrams get a little bit more confusing, right? So let's look at this diagram. We have this segment, okay, so this is B, C, D, and this is point A and point E, and we have angles 1, 4, 2, and 3. Okay, so again, what we're trying to do is identify the two lines and the transversal that make the angles. Okay, so example 3. What if I want angle 1 and angle 2? Okay, so angle 1 is made up of this one and that one. Those are the two sides of that angle. Angle 2 is made up of this one and this one. Okay, so the one that they share, which would be line AC, okay, this is the one that they share. That would be the transversal. And the other two lines that make up the angles would be the two lines that are intersected by the transversal. So the two lines in this case would be line BA and line CE, and the transversal would be line CA. Okay? All right, let me go backwards here because I want to get rid of the lines. So hopefully you've already got that copied down. Okay, so now let's look at number 4. What if I want angle 2 and angle 3? Okay, so again, identify what lines make up angle 2. So angle 2 is this one and this one. Angle 3 is this one and this one. Okay, so the two lines are going to be line CA and line DE, and the transversal is going to be the one that they share, which is line CE. Okay? All right, let's do one more example here. Okay, so in this case, I have this diagram. Okay, this is G, this is F, this is K, this is H, this is I, and this is J. And we have angles 7 and 5, 6, and 8. Okay, so what if I want angle 5 and angle 6? Okay, so again, let's identify angle 5 is made up by this line and that line. Angle 6 is made up of this line and this line. Okay, so notice that if you look carefully and identify what makes up each one of the angles, then it's very easy to identify the two lines in the transversal. So the two lines would be GF and HK, and the transversal would be line FI. Okay, because that's the one that they both share, right? Okay, so what if we want number 6, angle 7 and angle 8? Okay. So 7 is made up of this line and this line. Angle 8 is made up of this line and this line. Okay, so in this case, the transversal is going to be GJ, line GJ. Okay, so the two lines are line FG and line HK, and the transversal is going to be JG, line JG. Okay. So again, we noticed that we did a lot of examples identifying where the transversal is, because that's super important. Okay. Now, when we have two coplanar lines cut by a transversal, okay, notice that several angles are created. Here's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different angles created. And so what we want to do is be able to identify those angles by their location. Okay, so notice that these angles and these angles are outside of the two lines. So we would say that this is the exterior. Okay, so that's the exterior. And notice that these 4 angles are between the two lines. Okay, so because they're between the two lines, we would say these are interior angles. Okay, so in our picture here, the exterior angles would be angles 1, 4, 5, and 8. So angle 1, angle 4, angle 5, and angle 8 are all exterior angles because they're outside of the two lines. Okay, the interior angles in my picture would be angles 2, angle 3, angle 6, and angle 7, because those are between the two lines. Okay, then we even get more specific. We have what are called alternate interior angles. Okay, so alternate interior angles are interior angles, so it has to be one of the angles inside, so either 2, 3, 4, or 7. But it says alternate, which means on alternate sides of the transversal. So angle 2 and angle 6 would be alternate interior angles. Okay? Also, notice that angle 3 and angle 7 are interior angles on opposite sides of the transversal. So those are another pair of alternate interior angles. Okay, so angle 2 and angle 6 are alternate interior angles because they're interior angles between the two lines. Okay, but they're on alternate sides of the transversal. Okay, so that's what makes them alternate interior. Then we can also talk about same side interior angles. Okay, and that's exactly what it says. Interior angles on the same side of the transversal. So in our picture, that would be angle 2 and angle 3 would be one pair, and the other pair would be angle 7 and angle 6. Okay? Now the way that we abbreviate these is this, we would just say exterior angles. This one would just be interior angles. This we would say alternate interior angles, and this one would be same side interior angles is the way that we would abbreviate that. So let's look at an example. So I have line A and line B, line C and line D. And notice that now I have actually 16 angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay? So, remember that in order to identify the angles, you have to identify the two lines in the transversal and then their relationship to those two lines. So if I wanted to know the relationship between angle 2 and angle 4, okay? Oops, I'm sorry, I got ahead of myself here. Let's go back up here. I forgot the last definition, corresponding angles. Okay, corresponding angles are angles in the same position in relation to the line and the transversal. So for instance, angle 1 is above, or we'll say to the left of the line and above the transversal. Angle 3 is to the left of the line and above the transversal. So we would say angle 1 and angle 3 are corresponding angles. Okay? Also notice that angle 2 and angle 4 are to the right of each line and above the transversal. So they are also corresponding angles. So angle 2 and angle 4 are corresponding angles. Okay? So what would be another pair of corresponding angles? How about angle 8? What angle would correspond to angle 8? Angle 8 is to the left of the line and below the transversal. So what other angle is to the left of the line and below the transversal? That's right. Angle 6 would be a corresponding angle. Okay? And then angle 5 is to the right of the line and below the transversal. So what other angle is to the right of a line and below the transversal? So that would be angle 7. Okay, so notice that we have 4 different pairs of corresponding angles. All right, so back to our example. So angle 2 and angle 4. Okay, so angle 2 is formed by this line and this line. Angle 4 is formed by this line and that line. Okay, so in terms of the picture, 2 is to the right of the line and above the transversal. 4 is also to the right of a line and above the transversal. So we would say that those are corresponding angles. So these are examples of corresponding angles, and that's the way that you would abbreviate it. All right, how about angle 7 and angle 12? Okay, so first locate angle 7. So angle 7 is formed by this one and that one, and angle 12 is formed by this one and this one. So in this case, our transversal is B. Okay, so we have angle 7 and angle 12 are on opposite sides of the transversal and between the 2 lines. So remember that those are called alternate interior angles. So these would be alternate interior angles, okay? Because they're on opposite sides of the transversal and they're between the 2 lines, okay? How about, let me get rid of the colors here. So these were alternate interior angles. How about angle 10 and angle 11? So again, the key is identify what makes up those angles. Angle 10 is made up by this line and this line. Angle 11 is made up by this line and this line. So line D is the transversal. So angle 10 and angle 11 are both inside the 2 lines and above the transversal. So they're on the same side of the transversal. So we would say that those are same side interior angles. Okay, and we just write that SS interior angles. All right, how about angle 5 and angle 10? Okay, so angle 5 is formed by this line and this line. Angle 10 is formed by this line and this line. So notice that A is our transversal, okay, and angle 5 and angle 10 are both inside the 2 lines but on opposite sides of the transversal. So we would say that those are alternate interior angles. Okay, oops. So these are alternate interior angles. Right? How about angle 14 and angle 15? Okay, so angle 14 is made up by this line and this line. Angle 15 is made up by this line and this line. So again, D is our transversal. So in terms of our transversal and our lines, 14 and 15 are inside the 2 lines and below the transversal or on the same side of the transversal. So we'd say that those are same side interior angles. Okay, and how about angle 3 and angle 11? Okay, well, angle 3 is formed by this line and this line. Angle 11 is formed by this line and this line. Okay, so let's look where angle 3 is. It's to the left I'm sorry, it's above the line and to the left of the transversal. 11 is above a line and to the left of the transversal. So that's what we call corresponding angle.